Welcome dear students, welcome to lecture number 11 of Advanced Information Systems course. Today we'll talk about the RDF syntax in XML and we'll talk briefly about RDF schema. So we'll talk about XML-based syntax of RDF and some of the basic concepts of RDF schema. Well, in the last lecture also we saw that every RDF document in XML starts with RDF as root element. Every XML document has a root tag, so RDF is the root tag, root element, and inside this tag there are a number of descriptions. Every description gives one or more statements about the resources, describes the resources. Now a namespace mechanism is used in all the XML documents. It is coming from XML layer. There are two purposes for this. One is for disambiguation and the second is the collaborative knowledge or reuse of knowledge. What do we mean by that? So let's take the example. Here these are the namespaces. In the root tag we have three namespaces. So it simply means that this document has certain structure, certain schema defined in it, and I have assigned it the shortcut as RDF. Similarly, this document, whenever we want to use anything from this document, we will use XSD to refer to this document, and similarly for this one, I'll use UNI. Okay, so these are user defined. You can define by yourself, you can give it any name. It is like a shortcut to be able to refer to a particular document. For example, I'm using here description, and from where I'm using it, I'm using from the base RDF document, this one. Okay. Similarly, in my own domain, let's say I'm talking about universities, I have defined some concepts like name, title, age, all of them, they are defined in this particular document. Okay, so inshallah at the end of the lecture today, when we talk about RDF schema, we will see how we do this. So this vocabulary or the language, it is defined in this schema, RDF schema, that can be referred by using the namespace mechanism, right? So namespace is nothing but a shortcut to some documents from which we are using any elements, okay, from which we are using any tags, right? So to disambiguate, maybe I use word, let's say pipe. In this document it means something, but in this document it means something else. So when I'm referring to pipe in this document, I'll put it as RDF :pipe, and when I'm using from this document, I'll use it as UNI :pipe. So I can disambiguate, and many people, they have defined many things. So we can reuse that knowledge in our own RDF documents. So we have some namespaces at the beginning of every XML document, and inside this we have number of descriptions. Like here in this document, I have one description, okay, about 949318. So whose name is David Billington, title is associate professor, and age is 27. It looks like I'm talking about a faculty member. He is an associate professor, his name is this, and age is this. Similarly, here we have a description about a course. We have a description about another course. So we have several descriptions within the RDF document, so it is a closing tag which will close all the document descriptions. Now in RDF description, there are two ways of referring to the resources we discussed in the last lecture also. If we are referring to an existing resource, we can use it by RDF about, or we can create a new source by using RDF ID. Now, content of RDF descriptions are the properties. So this is a description, okay. I'm making a description about this resource, and inside this I have these two tags, they are the properties. So for example, for this resource, two properties are course name and is taught by. Okay, so these descriptions, they are read conjunctively. It means they are ended together. So it essentially means, this description, it means that the resource CIT 3116, its course name is knowledge representation and it is taught by Gregorius Antonio. And so all these descriptions, they are ended together. Data types. We also discussed in the last lecture that many times for literals, we prefer to use typed literals. We also mentioned type with it, and we can reuse any existing type like the standard XML schema document. Over here we are using integer data type and the value is 27, or you can have any other externally or internally defined data types that can be used in the document. Now, if I take you back to the previous descriptions, here we had a description about a faculty member, David Billington, whose name is David Billington and title is Associate Professor. And in the next description, this particular course, it is taught by David Billington, right? But there is a problem in this description. This relationship between this course CIT 1111 and David Billington, it is not uniquely identified. I mean, David Billingtons can be many. So which David Billington are we referring to? Is it the same David Billington that we have put over here, or it is someone else, right? So the relationship, they are not formally defined, but they are there because of only the string, text string. And you know that strings cannot be they cannot be trusted. So if we have identifiers, then we can say, okay, this identifier is used in two places, so it is the same thing that we are talking about. So to force this thing, we can use RDF resource attribute defined in resource description framework. How we use it? So we want to make this binding between the course CIT 1111 and David Billington more stronger. So we can say that this course is taught by this resource, and this resource is defined over here, 949318. So all of you know that all the resources, they are unique, right? So they are unique. So now we are dead sure that this course is taught by this David Billington, because now we are not referring to it by text, but we are referring to it by resource identifier. So we can use RDF resource attribute to make this binding more stronger. Another thing is that in RDF, we can have a description within another description. Okay, so any description can be nested inside any other description, and the scope of this nested description, it still remains global. It means it can be accessed by any external document anywhere on the World Wide Web. There is no difference in the scope of the description by nesting it. So for example, here I can make it even more explicit. This course is taught by, and now I have nested another description inside it. It is taught by resource 949318, whose name is Billington, whose title is Associate Professor. Okay, so now I have nested this description inside the larger description. Another thing, if you observe the descriptions we have talked about so far, they fall into two categories. The courses, we are talking about CIT 1111, core discrete math and other courses, and we are talking about lectures. Now this information is clear for the human beings. Anyone who is reading these descriptions, they can make sense of it. Okay, discrete math is a course. David Billington is an associate professor, so he's a lecturer, and so on and so forth. But again, if we go back to the purpose of semantic web, it is not for human understanding, it is for machine understandability. So for machines to make it very clear that this thing is a course, this thing is a lecturer, we use RDF type attribute. Okay, so let's see. For example, here I'm talking about CIT1111, and I can say that the type of this resource is course, which is defined in this document. Okay. Similarly, we are talking about 949318. To human being, it looks like a lecturer, but to make it more explicit, I can mention its type as lecturer, which is defined in this document. Okay. So these documents are basically RDF schema documents, RDFS. We'll talk about them later, inshallah, in the coming slides. So this schema defines what is a course, what is a lecturer. All that language is defined over there. So here we are just linking our descriptions with those descriptions, with the definition of those things. So to make it very clear, we can clearly mention the type of this thing as a course, mention the type of this thing as a lecturer, and so on and so forth. Container elements. Up till now, we have been making description about single things, one course, one lecturer, and so on and so forth independently. Sometimes we want to say something about a group of things. Okay, let's say we may want to talk about courses given by a particular lecturer. We can have many descriptions. The particular lecturer teaches discrete math. He teaches let's say biology, it teaches chemistry, it teaches math, and so on and so forth. But if we want to make all the things in one group, we can use container elements. Okay, so container, as the name implies, it gives you a facility to put many items in one basket and then make a statement about this set of items. Okay. So there are three types of containers: bag, sequence, and alt. If there is no order of the elements, we can use a bag. Like in bag, we just put elements without any order. Sometimes the order of elements is important. In that case, we use sequence. And sometimes there is alternate items. Any one of them will be applicable at a particular time. So we can use RDF alt type of container. So these are three types of containers, and an example of each one of them is also given on this slide. For example, here we are saying that we are talking about a lecturer, Gregorius Antonio, and the courses taught by him are CIT 1112 and CIT 3116, and we have put them in a bag. This bag is closed over here. So it means this instructor, he teaches 2 courses, and we have put them here. Even if there are 10 courses, we could have mentioned all of them within one list. Okay, so this is an example of bag. Similarly, here is an example of alternative. So like we want to say that discrete math is either taught by this or by this lecturer, either by 949315352 or by 9493118. So we have used RDF alt element. It means at a time any one of these lecturers will be teaching discrete math course, but both will not be teaching at the same time. Right? We can also attach an ID attribute with a container if we want to make it more open, I mean more accessible. So if I assign an ID to a container, anybody can access this entire container with just an ID and make more statements about these containers. Right? For example, here I have given an ID to this list of courses. Alhamdulillah. Pardon me. So this list of courses is given an ID, DB courses. So now it becomes a resource. This list becomes a resource, and now you can make any description about this list but just by using this resource identifier, right? So if you want to make it reusable so that anybody else does not have to make the same list again, you can also assign an identifier to the list. Collection. Sometimes we want to group a set of items together, and we also want to close the group. Okay, let's say I want to say that discrete math can be taught by these two lecturers, but it cannot be taught by anybody else. I want to close this list. So in the containers, the list remains open. If I say that discrete math is taught by one of these instructors, then there's no way of saying that nobody else can teach this course. Or if I say that this instructor is teaching these two courses, there's no way of saying that he is teaching only these two courses. He cannot teach any other course. So if the requirement is such that I want to say that the list is complete, I want to close the list, then I can use collections for that. Okay. So it is constructed by using these elements. Okay. Or there is another way also, we'll see in the next slide. You can just mention RDF parse type as collection. Once I have mentioned this group of items as collection, it means now this list is closed. Let's say this course CIT 2112, it can be taught by either this lecturer or this lecturer or this lecturer, and that's it. Nobody else can teach the course. So if you want to close the list, we can use collection as RDF parse type. Reification. We discussed in the last lecture also that sometime we want to make statement about another statement, like to discuss, to mention your belief or liking or disliking or trust or any statement you can make about another statement. So reification is the process that allows us to make statements about the statements. Okay. So how we do that? In the last lecture also we saw that we identify individual components of the statement, okay, the subject, the predicate and object, and we assign an identifier to this group. For example, here I have a statement. The statement is the resource 949352, its name is Gregorius Antonio. Okay, so this is subject, okay, this is predicate, the property, and this is the object. Okay, so I'm making a statement about a subject 949352, and the statement is the name of this resource is Gregorius Antonio. So now in reification over here, if you see, we have reified this statement. What we have done, let me go inside first. So I have identified that the subject of this statement is resource 949352. It is referring to this one. The predicate is name defined in this document. So it is referring to this. And the object is this value, which is referring to the value of this attribute or the property, right? So, and we have divided this statement into three parts, and the thing we have done over here is we have given it an ID. So now this entire statement is given an ID. The ID is statement about 949352. So now if I want to make any statement, like over here I have made a statement about this resource, okay, so now I can make any statement about this resource. Now this resource is not a resource, but it is actually a statement. I hope you understand that by reification we segregate, we divide a statement into three individual parts, subject, predicate and object, and we assign it an identifier which makes it a resource. And now you can use this resource like any other resource in RDF, and you can make as many statements as you like, just like you can do for any other resource. Okay, So these parts, subject, predicate, and object, they allow us to access individual parts of the statement. And now this ID that we have just assigned, it can be used to make any description statement or any other statement for this statement. So I hope now you can understand that RDF is a very simple and elegant way of describing the resources, and we have seen the XML-based syntax, and I hope you can go through this entire material by yourself and you can easily understand the constructs, the facilities provided by RDF. Now, so far we have talked about RDF. The next thing is RDF schema. RDF is a universal language that allows a user to describe their resources in their own vocabularies. Okay? In their own vocabularies. Who defines the vocabulary? Okay? The vocabulary that we have been using so far, let me take you back to this slide, like here, to give you some example of the vocabulary. Vocabulary we have been using so far is, let's say, course name is taught by, name, title, age. Okay, so all these vocabulary, plus there is some vocabulary defined in RDF like description, like ID, right, like type. All these vocabulary is defined somewhere. Okay, so from where I'm using it from, let's say, this vocabulary, course name or is taught by or name, title. I'm using all of them from university, UNI. And if you remember, this is a namespace which is referring to a particular document. So where I have defined all the vocabulary, if I take you all the way back to the first slide of today, okay. Sorry. Look, this is the document http://mydomain.org/uni/-ns. I have defined all the vocabulary in this document, and when I'm using any word from this, I use this namespace UNI, this shortcut, to refer to this. So I have defined what is a course, what is a lecturer, what is name, title, age. So all this vocabulary, all these terms, they are defined in this document. And the thing that allows me to describe all these things, that is called RDF schema. Just like in any XML document, we have XML schema, which defines a logical structure of any domain, any document. Similarly, this schema allows us to define logical structure of any RDF document. There are some differences as well, but we'll not go into that. But roughly, you can compare RDF schema with an XML schema, that both they define the logical structure of the domain about which you are talking about, right? So let's go back to our main thing. I hope now you understand the difference between an RDF document and RDFS document, right? So RDF does not assume this vocabulary, nor does it define semantics of any particular application domain. The user can do so in RDF schema. So in RDF schema, we can define classes, we can define properties, we can define class hierarchy, we can define property hierarchy, and some other things also we discussed today. So we must distinguish between concrete thing, individual objects, like discrete math is a concrete thing, is an individual object. David Billington is a concrete thing. And the set, the general things, the classes, lecturer, student, course, so all these are general. I believe all of you are familiar with the object-oriented paradigm, like Java or C++. So basically, these are classes. If you compare it with object-oriented paradigm, these are classes, and what are these? These are objects. Just like classes are general and the objects, they are specific, they talk about individual instances of the classes. Similarly, in the RDFS, this is RDFS. When we are talking about general things, lecture, student, courses, we are defining the vocabulary, it is RDF. And when we are talking about the individuals, instances of these, then it is RDF. So RDFS defines the vocabulary, it defines the domain, and RDF, now we describe the individual resources, right? And the relationship between these two is established through RDF type. We have seen it before that we are talking about a course and we want to say it is a course. We associate it with RDF type element. We are talking about a lecturer and we want to say it is a lecture. We associate it with RDF type. If you can recall the statements, this thing is a type of course and how they are linked together through RDF type element. This thing is a lecturer and how they are tied together through RDF type attribute. Okay. So why we need, the first thing in RDF schema is classes. Why the classes are useful? I hope you can understand the concept more easily having some background in object-oriented paradigm and programming. So just like in programming languages, they disallow nonsense from being stated. What do you mean? Let's see some examples of nonsense statements. Discrete math is taught by concrete maths. Well, it is a nonsense statement, right? So we should not be allowed to make a nonsense statement. Let's say this is a property is taught by. So what type of values it can have? A course should only be taught by lecturers. Okay, so if we define a type of lecturer, now I can say that the value of this property should be from lecturer class only. So lecturer class provides me the capability to say that the value of this property cannot be anything other than a lecturer, right? So this is called range restriction. What type of values a property can have? So it is on the right side. Similarly, we can put the restrictions on left side of the property. Let's say again is taught by. So this is called domain restriction. What values can this property be applied to? So here we are applying this property on room. Room MZH5760 is taught by David Billington. Now here it is correct, the range, but the domain, a room cannot be taught. We should say that only courses can be taught. So we can say that we should put a restriction over here on the domain of this property, that this property will only be applied to courses, the type of instances, right? So we can, the classes, they allow us this facility so that the nonsense statements are not allowed by restricting domain or range of the properties with the relevant classes. Similarly, class hierarchy, as all of you are familiar with object-oriented paradigm, a class is said to be a child class of another class if it inherits all the properties of the parent class, right? And it does not need to be a tree, okay? Subclass graph does not need to be a tree, which means that one class may be derived from multiple superclasses. So it will have properties of all those classes together if it is inherited from multiple classes. Over here we have a small example of class hierarchy. We have seen it before as well. Anyway, staff member is a concept, and there are two concepts derived from this, sorry, three: administrative staff, academic, and technical staff. From academic staff, we further have three concepts: professor, associate professor, and assistant professor. So a very simple class hierarchy. It means all academic staff members are staff members, all professor are academic staff members, all associate and assistant professors, they are academic staff members, and they are also staff members. So the range restriction, courses must be taught by academic staff members. Let's say we have put this constraint on the courses property, okay, taught by property, and if Michael Maher is defined as a professor, he inherits the ability to teach, this teaching ability from academic staff members. So if we have put a restriction over here that the courses must be taught by academic staff members only, and if someone belongs to this class, then he will inherit the property from this parent class. It is a simple inheritance mechanism. Okay, this is done in RDF schema by fixing the semantics of is subclass of. So we can say that a professor is subclass of academic staff member. Associate professor is subclass of academic staff members, and so on and so forth. Property hierarchies. So just like we have concept hierarchies, we can also have the property hierarchies, or the class hierarchies and the property hierarchies. So for example, is taught by is a sub-property of involves. So maybe we have a parent property involves, and we have defined a sub-property is taught by. So every course involves certain instructor, but every instructor might not be teaching it. So teaching is a specific property. If someone is teaching, then he is involved in the course, but not the other way around. Maybe someone is involved in the course, but he just, let's say, marks the student exam papers, but not actually teaches the course. So we can have the property sub-property hierarchy as well. So to summarize the whole discussion, we can, in one slide, we can see RDF layer versus RDF schema layer. Okay, so the schema is itself written in a formal language, RDF schema, that can express its ingredients like subclass of, class, property, subproperty, resource, domain, range. Okay, so all these things, they are defined in RDF schema, and when we talk about the specific things, they are defined in RDF. For example, this is a very small example of a schema in which we are saying that we have some academic staff members, and there are two properties. Every staff member has phone and ID. The domain of phone is staff member, range is a literal, it can be any number. Similarly, ID has same. Academic staff member is subclass of staff member. Course involves academic staff member, and there's a subproperty is taught by it. Every course is taught by academic staff member, and so on and so forth. So this thing, if you see over here, this line separates RDFS and RDF. So RDFS is about general things. Over here we are talking about the general vocabulary. And if we see over here below this RDF document, we are talking about specific particular things like discrete math and how we link it with the class through type element. So the type of discrete math is course. Similarly, the type of David Billington is associate professor, and how they are linked together by this property is taught by, which is coming from here, and its domain is course and range is academic staff member. So to summarize, we can say that RDFS gives us a vocabulary that can be used in RDF document by a user to describe their own resources, right? So again, RDFS and RDF, they are very simple, elegant frameworks which allow us to define our resources, but there are some utility properties that can help you increase the readability, understanding, and reuse of the documents. Like C also, sometime there is more information about a resource somewhere else, so you can say that C also, we can attach this property, is defined by, it is sub-property of C also. Sometimes some resource is defined by some other resource, so we can refer to it by is defined by. Comment, similarly, sometimes we can attach a human readable comment with any class so that the readability will be improved. Label is also a comment, but mostly it is short, 1 or 2 words that are used to describe anything. So basically all these properties, they improve the human readability. They are not for machines, they are mostly for human readability, because in a distributed environment we can imagine that many people will be using the descriptions of each other. They will be sharing and reusing lots of knowledge. So all these utility properties, they help us in human readability. The human readability is improved for the RDF documents. At the end we have a simple example of a university ontology or university schema, RDF schema. So first of all we are defining a lecturer to be a class. So we are saying that there is a class of lecturer and we have given a human readable comment. Again it is for humans, for machines it is not much useful, and it is declared to be subclass of academic staff member. Okay. Of course somewhere else we will have a statement that academic staff member is a class. Over here we are saying that course is defined as a class, okay, and there's we also have a small comment with it. There is a property involves, okay, and the domain of property is course and the range is lecturer. We have given domain and range restriction. Okay, we have defined a property involves, and we have said that this property can only be applied to courses and it can have only value from the lecturer classes. Similarly, is taught by, there's a property is taught by, there's a comment that it inherits course and lecturer from the involves, and it is declared to be sub property of involves property, right? Similarly, over here we have defined a phone property which will have the domain as staff member, and the range is literals, which are defined in this document w3.org/RDF schema. So this is how we can define the structure or vocabulary of RDF documents by using RDFS. So RDFS gives us a way to define our own domain of interest. Let's say over here we discussed the ontology of universities, in which we define the classes, the concept of lecturer, course, name, teaching, and so on and so forth, the classes and properties. If I want to be able to describe computers, I will define the concept of, let's say, hard disk drive, RAM, screen, resolution, and so on and so forth. If I want to talk about business, I'll be talking about the finance, I'll be talking about money, human resource, job description, and so on and so forth. So by using RDFS, you can define any domain of interest. You can define the concept, you can define concept, subconcept, hierarchy, you can define properties, you can put some basic constraints like domain and range constraints, and then you can define your own instances by using RDF framework. But RDF provides us very limited opportunities. Inshallah, in the next lecture we will talk about ontologies, which provide us much more refined mechanism of describing the resources in a logical way. So inshallah, in the next lecture we'll talk about ontologies, what are their components, how we can build refined descriptions of domain, and then we'll talk about the semantic web applications. So that is the end of today's lecture. See you inshallah in the next lecture about ontologies. Assalamu alaikum wa rahmatullahi wa barakatuh.